So theorem of total probability. The first two conditions either for Bayes theorem or theorem of total probability is I am taking events A1, A2, A3 etc. any number of events. This n events, the first rule is they should be mutually exclusive. Do you remember what is mutually exclusive events? The occurrence of one event will never make the other all the other events to occur. Okay, those kinds of events are called mutually exclusive. And exhaustive means the second point. If you take A1, A union A2, union A3, etc., if you do everything, it will give you the whole sample space. Then the event are called to be exhaustive. So when you're going to apply Bayes theorem or theorem of total probability, these two conditions should hold. It should be mutually exclusive event, all the events, and union of all the events will give you the sample space, that is exhaustive. If these two conditions satisfies, then only we are going to use the concept theorem of total probability as well as Bayes theorem. Now you can see the picture, guys. A1, A2, A3 events are mutually exclusive. That means occurrence of one event will not make the other events to occur. Okay, and mutually exclusive means you know that one event occurrence will stop all the other events. Okay, so that particular event will alone happens. Now that means all A1, A2, An are mutually exclusive and exhaustive. I am taking a event B. So a event B cannot be a new one because A1, A2, A3, An are mutually exclusive and they are exhaustive. So B is any event which is associated with the A1, A2, A3 events. So I am taking a part inside. You can see the figure clearly. Okay, that is the event B. Now when you find the probability for that event B, P of B is called the total probability of the event B. Okay, so since you see B is associated with all the events, so P of B is nothing but if it is associated with A1, probability of A1 into probability of B bar A1, because we know that conditional probability. What is conditional probability? P of A bar B is equal to A intersection B divided by probability of B. Now you see, since B is an event associated with this events, so we can easily see this one. So B is associated with A1. So probability of A1 intersection B, automatically using conditional probability, we will get what? Probability of A1 into probability of B bar A1. Similarly, A1, A2, A3, A4, etc. If you take n events, you have to add all these things. So P of B is the total probability of the event B, which is nothing but adding this conditional probabilities. AI into probability of B bar AI. That's it, students. If you know this concept clear, so in exam point of view, we are not going to write the formulae, but solving problems, we are going to use a tabular technique, which makes the problem very easy. Let us go to the problem. So a factory uses 3 machines. Okay, whenever you see 3 machines means these are all the only possibilities. So I am taking A1, A2, A3 immediately after seeing the question. 3 machines. So I have three events. So A1, A2, A3 are the 3 events of that item produced by machine X, machine Y, machine Z. So these 3 events are mutually exclusive and exhaustive. No other machines are there. So this is the first data. And what else we have? What else they are saying? Okay, the machine is producing 50%, 30%, 20%. So probability of A1 is 50%, that means 0.5. Probability of A2 is 30% and probability of A3 is 20%, 0.2. Okay, this is what the data given. Now, out of this 50%, 3% are defective. Now you understand. So event of defective, it is associating with the machines X, Y, Z. Okay, so now I am defining a new event. This is called B. Okay, B is the event of getting defective item, because an item may be good or defective. Now I am taking B is the defective item. So the defective item may be come from machine 1 as well as machine 2 as well as machine 3. Now you see defective items come from machine 1. That means probability of a defective item come from machine 1. P bar A1. Probability of a defective items comes from machine A2. Probability of a defective item come from machine A3. Now you understand the concept, I think. Now what we are going to do, so probability of a defective item from machine 1 is 3%, 0.03. Machine 2 is 0.04. Machine 3 is 0.05. Done, students. So A1, A2, A3. From this we have find their probability, defective item probability from each machine. Now let us see the question. Find the probability that a randomly selected item is defective. Randomly selected item is defective means either it should come from machine X or from machine Y or from machine Z. So once you see the word either, that means it is simply going to be your addition theorem. Okay, so probability of B, either it's come from machine X or it comes from machine Y or it comes from machine Z. So we are going to add. So a defective item come from machine X, possibility is P of A1, probability of B bar A1. This is by conditional probability, students. So for machine Y, A2, probability of B bar A2. For machine 3, A3, probability of B bar A3. That's what we are going to explain in the next slide. You can see the next slide. Defective item produced by X. Probability of a defective item from A, machine 1, machine 2, machine 3 or XYZ, whatever it is. So now you see we have only 3 events, A1, A2, A3, and the defective events are B. So B is associated with all these 3 events. Now you understand the clear idea. So this figure is for your understanding, not for exams. Okay. Now I am going to make a table. If you make this table successfully, problem over is. First write the events in first column. First column write the events A1, A2, A3 and their probabilities. Probability of A1, just now we have found in the previous slide. Probability of A1 is 0.5, 0.3, 0.2. Then probability of the defective item from A1, 0.03, from A2, A3, and then multiply column, always multiply. We are going to use only 4 columns, students. First column data, second column probability, third column the event B or some event which is associated with this. Always multiply column 2 and 3 and form a new column 4. Okay, so now we have this data. Finally, add column 4. Add the values in column 4. So you will get P of B, that is my total probability, students. So in exam point of view, you make the table and write this is total probability. And for your understanding, I am writing the steps. In exam, you don't need to write the steps. You can simply write from the table. From the table, we easily get P of B is going to be 0.037. Directly, you can write this step. Okay. So this will be easy for you instead of remembering the formula. So this is the probability that you choose any item which is going to be defective. That's it, students. Hope you understand. Next we go for Bayes theorem. So Bayes theorem, if you know the theorem of total probability, then Bayes theorem is very easy. The same condition, A1, A2, A3, exhaustive, mutually exclusive. B is another event which is going to be associated with all AIs. Now, what is the probability that I am selecting an item from A1 provided it should be defective or it should be that event associated with B is nothing but, this is nothing but probability of A1, probability of B bar A1. This is because of this is because of conditional probability divided by probability of B. This is nothing but what? Total probability of B. Okay. So simply using the tabular column, we are going to get the value. Okay. So either you can use this formula or you can directly say this. So just use this formula or this formula, write this, and using the table you can find the solution. So if I go to the problem, then you can understand, students. Okay, now let us see what is the problem given to us. Okay, two events are there. Machine 1, machine 2. So A1, A2. This is machine 1, machine 2. We can write A1 be the event produced by machine 1, items produced by machine 2. We can write this down. And as usual, defective items. So B is going to be the event of defective item. So that means, so 40%, 60%, 4%, 5%. Let us go to the table, fill the table, and we'll come back to the question. Okay. So probability of A1 is 40%, probability of A2 is 60%. So this is going to be 0.6 and this is going to be 0.4. And this figure will give only two events are there. B is the defective event of selecting defective item. So it is associated with A and B. This is for your understanding, not for exams. In exams, don't draw this. Okay. Now you see what I am going to do. A1, A2, two events. Probability of A1 is 40%, 0.4. Probability of A2 is 0.6. Then they say, let us come to the question. 4% of item produced by machine 1 are defective. That means defective item from machine 1, 4%, 0.04. Defective item from machine 2, 0.05. So first column event, second column probability, third column defective item from particular machine, and fourth column multiplying 2 and 3. You get this. So if you add this, you will get the total probability of the event B. Okay, total probability of event B. So this is what we are going to use in the denominator. For your understanding, I have written here. Okay, so in exams you don't want to write this also. Okay, because from the table, single word you can write. From the table you can get. So now let us go to the question. So we have formed the table. An item is drawn at random. If the drawn item is defective, so an item is drawn random, it is defective. Defective is the condition already imposed. Find the probability it was produced from machine A2. This is the machine 2. This is what we have to found, student. Here you cannot use, they are not asking total probability. An item is drawn, the drawn item is defective. So that means defective is the prior condition. Find the probability that it is coming from machine A2. So now let us go to the table. So you don't want to do much steps, nothing. You see the table alone. For your understanding, I am writing all these wordings. In exam point of view, so what you have to do, probability of selecting a defective item from machine 2. It is nothing but probability of A2 into probability of B bar A2 divided by total probability of event B. Write this formula A2 means. And just close your eyes, it is very simple. A2, then go to the final column, column 4. Column 4 here it is 0.03 and total we have already done 0.046. So if we do in calculator, we will get 6.22. That's it, student. Identify, they are asking probability for which event, and go to the fourth column, take the event to the numerator and total to the denominator will give you the answer using Bayes theorem. This formula is using Bayes theorem. Now even if you forgot the formula, go to the table. P of AI, probability of B bar AI, event is A2. So P of A2, P of B bar A2 in the numerator and total probability of the event B at the denominator. That's it, student. So in a very simple way you can solve the problems. Now let us see the question. So now in this question it is very important. They are using 3 machines ABC. So A1 is the event from machine A, A2 is the event from machine B, A3 is the event from machine C. So now I cannot use the data of B because B is already repeated. So if a bolt is drawn random, okay, so what is defective? So for defective, what I am doing, I am taking a notation D. Okay, since A, B, C is there, always need not to be we take B. I am taking notation D. Okay, now it's clear. So now our job is to form the table. So you see A, B, C manufacturing 25, 30, 40. So probability of A1 25%, 0.25. Probability of A2 0.35. Probability of A3 0.40. Total of this their output 542% are defective. That means defective item from A1. So what is the defective item from A1? Defective item, yeah, I am using D. Okay, defective item from A1 is 5%, 0.04. Defective item from machine A2 is 4%. Defective item from machine A3 is 2%. Done, students. So now column 2 is ready, column 3 is ready. When you multiply, column 4 is ready. Problem over. Okay. So now let us see the question what they are asking. What is the probability that the manufactured item it's found to be defect? Okay. If a bolt is chosen randomly, it is defective. So defective is fixed. What is the probability that it would come from machine? Sorry, defective means we are using D here. What would be come from machine A, B, C? So we have to find A1. Oh, here we have to find everything. Probability of A3. So now see the table, students. As I said you, A1, A2, A3 are the events. Column 1. Column 2, their probabilities. Column 3, defective item produced from A1, A2, A3. Okay. Then column 4 is multiplication of 2, 1, 3. Now make a total, that is called total probability of event B. Okay, so just now you get it. Now it is very easy. In the question they are asking what is the probability that a defective item is chosen from A1, defective item chosen from A2, defective item chosen from A3. So it is very simple, student. For A1 you have to 125, you see here also 10,000, total probability is also denominator 10,000. If we divide this, for A1 125 by 345, for A2 140 divided by 345, for A3 80 divided by 345. So that's what I am explaining here, you see. So we have found the total probability. Bolt manufactured by the machine A, already defective is fixed. Bolt manufactured by machine A, which is defective, manufactured by machine B, which is defective. Okay, so for your explanation I am writing here, but directly from the table you can do this. Okay, so I have just given you for your information. Okay, this is by 100. Okay, here some typo, 35 by 100. Done, students. And finally, there is one trick. If they ask you to find everything, now you know the probability of this 2, and they are asking what is the probability that item produced by A3 which is defective. We know there is only 3 possibilities, right? So 1 minus probability of A1 by D plus probability of A2 by D will give you probability of A3 which is defective, because this is total probability is 1. We know this formula. So either I can use this, or sir we are confused, we don't make us confused. Then if you think like that, then probability of A3 means 80 divided by 10,000 whole divided by 340 divided by 10,000 you can do. So either you can use this technique, that is also correct, or if you use the normal way, classical way, that is also correct. You are going to get the same answer. That's it, students. I think hope now you are so confident with Bayes theorem, whatever the problem comes, you can analyze. You see, one more problem I will do. A factory produces certain type of output of 3 machines. Immediately A1, A2, A3, right, events. Cost 1% of the machine defective. So defective means you can take B or D. Let me check what I take. I have taken B because we have A, not A. So B is for defective item. Good. So now you see, I am taking this. So A1, A2, A3. So A has 3000 units, B has 2500 units, C has 4500 units. Past experience shows 1% output are defective, 1.2, 2% are defective. Okay. So now in this case, you see percentage is not given, guys. So now machine A is producing 3000 units, B is producing 4000 units, C is producing 2500 units. So we need to find what is the total units. So 3000 plus 4500 plus 2500. So 7, 8, 9, 10,000 units. So total units is 10,000. Okay. Now probability of units produced by first machine, that is A1, is 3000 divided by 10,000. This is how you found the probability of A1. Okay, it's going to be 3 by 10, simply 0.3. A2 now is 2500, so 0.25. A3 is going to be 0.45. So now we found A1, A2, A3. Errors are given in percentage, so it is very easy. 1% means 0.02, 0.012, 0.002, 001, 0012. Done, students. So once you understand this concept, you see problem over here. So how this comes? The total data is 10,000 from 3 machines. That's what I am writing. Probability of A1, A2, A3. Defective items we have written. Now let us go to the table. Enjoy the problem. First column, events. Second column, probability of this. Third column, defective and their probabilities. Fourth column, multiplication. And you get this data, add this. This will give, okay, if here it is B, okay, this is going to be B. This will give the answer, guys. Okay. So this is some typo. Yeah. So the total probability is going to be 0.015. Now let us go to the question what they are asking. An item is drawn random, day's production, found to be defective. An item is drawn, it found to be defective. What is the probability items come from A, that machine A, B and C? Okay, now you see we are using A, B, C. That's why we are using defective item is D. That's okay, good. So that means this is correct. Here I have to change. It should be defective item. Okay, this is correct then. Yeah, you should be careful about your notations. Here I am going to change this defective item because A, B, C are the machines. Okay, students, done. Now from machine A means 0.03 divided by 0.015. Similarly, both the cases this. For machine C, 0.09 divided by 0.15. Done, students. See, machine A is going to be A3, or if you are confident, what you have to do? You can do in the other way. If you add 0.2, 0.2, it's 0.4. Subtract with 1, you will get A3. That's it, students. And there is one more final problem in this topic. It's different. Just to understanding, I have taken this question. A urn contains 5 balls. If you have so much data, problem is easy. If you have less data, problem is tough. Tough means we have to form it. Urn contains 5 balls. 2 balls are drawn and found to be white. What is the probability that all the balls are white? Okay, so the urn is containing, now you take the urn, it has 5 white balls. Okay, we are drawing 2 balls outside. We are taking 2 balls outside from this 5. What is the probability that all the balls are white? It's very interesting. So if we have to draw 2 balls outside, then 100% 2 balls should be white. If only 1 ball is white, the event will not happen. So I am taking A1 is the event with 2 balls. Maybe it should have 3 balls white. It should have 4 balls white. Finally, it should have all the 5 balls white. Now, my aim is to find the probability that all 5 balls are white. So that means probability of A4 provided some event. So now you see they are equally likely. Okay, out of 5 balls, what is the chance? 2 are white, 3 are white, 4 are white, 5 are white. So we have 4 events here. So each event probability is going to be same. Like if head and tail means 50-50. If there are 4 events are there, each chances is total number of events 4. Each chance is 1/4, 1/4, 1/4 and 1/4. So what is the probability of 4 events would happen is 1/4. That's what I'm taking. Now B is the event that 2 balls are drawn from the box which has 5 balls. Okay, so first probability of 2 balls are drawn from the event A1. Okay, they both are white. So in A1 only 2 balls are white. So I am taking 2 balls from 5 balls. In A1 I have exactly 2 white balls. So the probability is 2C2. Okay, and for A2 we have 3 white balls. So 3 white balls means probability of getting 2 white balls from A2 is, the denominator is 5C2. Now 3 white balls are there. I can take any 2 combination. Similarly for A3 I have 4 white balls. So that means taking 4 white balls from 2, total is 5C2. And A4, it is very simple. A4 all 5 balls are white. So 5C2 divided by 5C2 is going to be 1. Probability of B A4. So now we have found these values. So let us go to the table. So first data, second column probability, that is 1 by 4, 1 by 4, 1 by 4. Third one, probability of choosing 2 balls or white from the given events. And column 4 is multiplying all these things. Now what the question says, what is the probability that all the balls should, the 2 balls are white provided they are taken from the box which contains all are white. You can see the question again, not understand. What is the probability that all the balls are white? That means what is the probability all the balls are white means A4 provided I am taking 2 balls from the thing. So A4 is there, it is 10 by 40 and total probability for the event B is 20 by 40 if you add. So 40 get cancelled. So 10 by 20, 1 by 2, it is 50% chances we have. Okay, I think now it is clear. If the question they are asking what is the probability that 4 balls are white means event A3 has 4 balls white. So you have to write 60 by 40, 20 by 40. If 3 balls white means you have to use this. So you have to use the appropriate data. That's it, students. So Bayes theorem, you don't want to worry. Formula is big. You can refer some books or some materials. So use this trick, make the table. I will again just explain. This will give you the events. Second one give their probability. Third one give their item which is defective or some item B which is associated with A. And fourth column will give the multiplication of 2 and 3 and you have to make the total of this. This will give P of B. This is going to be the denominator for our question forever. If they are asking what is the probability that A2 bar B, that means you have to take this one divided by probability of B. If they are asking A3, take this one and do divided by probability of B, the total. Okay, so simply I can say this row n data divided by this total will give you the answer for the question. Hope you understand Bayes theorem very clearly. Thank you, students.